Hi, welcome to L4M. In this video, we will see where three heights of an obtuse triangle intersect. Okay, where that point of intersection is located. If you remember in the previous video, plane geometry 12.2, we saw that point of intersection for the three heights of an acute triangle was located inside the triangle. And we also saw that the three heights of a right triangle intersect at the vertex of the right angle. What is the case for an obtuse triangle? Obtuse triangle means a triangle whose one angle is an obtuse angle, which means greater than 90 degrees. So let's draw such a triangle first and see how the heights are intersecting. Okay, you see this angle is an obtuse angle. Of course, we cannot have a triangle where more than one angle is obtuse, right? You will understand I believe that you know the reason, but we haven't seen it in this series of plane geometry lessons. Let's say this is the triangle A, B, C. Okay, I want to draw the height from vertex A to the line containing the opposite side. Opposite side is BC here. So you should understand here, that that height cannot be drawn like that. If I draw a height from A to BC, if I try to draw, I will understand that I cannot have a 90-degree angle here. This angle is, for example, even greater than this obtuse angle, and this angle, it's understandable that it's an acute angle, so we don't have a 90-degree angle here. So how do we draw? Remember the idea, or the definition of a height. Definition of height says that height is the perpendicular drawn from the vertex to the line, not exactly to the side, but to the line containing the opposite side. So where is the line containing the opposite side? The line BC. Let's extend the line segment and draw the line BC like that. So it's understandable that we can draw that height not somewhere on the line segment BC, but that height will be here. Okay, this height completely lies outside the triangle. So let's say this is AH1. AH1, let's write it here. AH1 is the height from A to BC. Okay, what about the height from vertex B to the opposite, to the line containing opposite side? It's obvious that we can draw it like that. So this is BH2. BH2, you see, it completely lies inside the triangle. Okay. So what about the third? And by the way, you see that the first height and the second height, they didn't intersect, right? They didn't intersect. Okay, let's see. BH2 is the height from B to AC. What about the third height? The third height should be drawn from vertex C to the opposite, to the line containing opposite side, which is AB. Again, you should understand that I cannot draw a perpendicular from C to here, to a point somewhere between A and B, somewhere on the line segment AB, because that angle will be an acute angle. It won't be an 90-degree angle. So how do we draw that height? Again, I will think about the line AB. I'm extending AB to show the line, and then I'm drawing the perpendicular from C to the line AB. Okay, so that will be CH3, let's say. So CH3 is the height which is drawn from vertex C to the opposite side AB. Not to the opposite side AB, but to the line AB, which contains the side AB. Okay, so I see that these three heights do not intersect, but we said that all three heights of a triangle intersect at one point. So yes, the altitudes AH1, BH2, CH3, these three heights, they didn't intersect, but when you extend them, let me extend this line AH1, let me extend the line BH2, and let me extend the line CH3. That won't be good, right? So I'm changing, because since I'm drawing these figures manually, I'm using my hand. That height CH3, it was not a perfect one, so let me show it like that. Okay, that CH3, which is perpendicular to AB, should be something like that. CH3. Okay, I didn't like where I put H3. Let me put it here. Okay, so when you extend CH3, the extensions of our heights in this case are intersecting at one point. But this point is now outside the triangle, right? Okay, I'm writing the conclusion. All three heights, no, not all three heights, but the extensions. I will write extensions, because heights themselves, they didn't intersect, their extensions intersected. The extensions of all three heights of an obtuse triangle intersect at one point, which is, that point is located outside the triangle, right? Which is, I will make everything a little smaller so that my sentence fit here. Okay, which is located, okay, which is located outside the triangle, or which is located in exterior region, right? Exterior region of the triangle, located outside the triangle. Okay, that's all. So I hope that you understood here that how we should draw the heights of an obtuse triangle. Two of the heights of an obtuse triangle, they should be outside the triangle. They don't lie. H1 and CH3, you see, they don't lie inside my triangle. Just one of them is completely lying inside the triangle, the line segment BH2, but their extensions in this case again intersect at a point, and this point is located outside the triangle. Okay, thanks so much. Stay with us, subscribe my channel, and support me, please. If you enjoy these videos, see you next video. Bye.